Hello, folks. We are back live. Few things to do today. Two different things. Let me pull that up and I will switch over to the stream view. All right. So, first and foremost here, new article. Right here. If you're interested in the latest in RL, I would suggest reading this. It's a pretty quick read, probably like a 5-10 minute read. I wrote this morning. Pop the chat out real quick in case we'll come on to discuss it. Because the bottom of it says, "Come yell at me if you don't like anything in here." Okay. So, yeah, this is pretty much just like a quick summary of the neural MMO training run that we did. I did the math. It's an absolutely ludicrous amount of data that it turns out. 6.2 petaflops. It's something like comparable to the total amount of training data used in all language models ever. So yeah, it's ridiculous. Hey, Melkor, that's Tosin, right? Welcome, man. We've released all sorts of stuff in the last little bit. So new articles here on that. And then aside from that, we started doing a little robotics. Got back from RSS. How'd that go? I will be at RLC in a few weeks. Actually, I got to buy my tickets. Important thing for me to remember to do. Good. Conferences can be hit or miss, so glad that went well. Last one I went to nearly killed me. That's because we Americans aren't as tough, though. You're dealing with, like, freaking malaria and shit. Like, oh no, my pneumonia. Like, yeah. Fix the driver problem. Need to install nightly. We tried to make it a little more stable in the latest as well. We added, like, some stuff. But yeah, there's tons of cool RL around here. It all actually works now, which is cool. So we're starting with robotics today. Let me think how I want to do this. 15 over 6 will be like 4 mil, 5 mil, like see what this does. We have robotic sims. I added a binding to Manny skill, which is a hell of a lot easier to use than a lot of the other ones. Also, Stone, friend of mine, works on this. I've been working on... We had some, like, basic tasks working, but we haven't really given them the full puffer treatment yet, where we've made them super, super fast or anything. Currently what we're doing here. Geez, what did I have to do to make this work? Oh, right, I forgot about this thing. Try this. Welcome, Phoenix. I'll show what this task is in a second here. Oops. Come on, Chrome. Stop being weird. Oh, Tetsuo saw this. That's cool. So this is Manny's skill. They have all sorts of robotics tasks. Late today, I had to write this article. Go read it. It took me a few hours to like write everything. I saw this at RSS. You might have even met Stone then. Stone's really cool in robotics space. He was probably there. We're starting with some of the simpler tasks. Like these 2-finger gripper tasks. Honestly, it's my intuition that doing stuff like this just really, really well could be like just as useful as some of the other stuff in robotics. There's a lot of the industry bots kind of look like this. They follow any specific temporal logic specifications or non-Markovian. So one of the best things that you can do in reinforcement learning for your own intuition and understanding of things is just completely ignore like the Markov property in everything. It's not relevant. I've sent a PR on the docs. What PR did you send on docs? See. I thought I merged this. Oh, for work in progress. Cool. Thank you. Let's see what we're getting in this train run. Okay, so this is not solving the task, annoyingly. Let's see why it's not solving the task. Difficulty using importable APIs. How so? Pufferel eval's not working? You gotta give me more information than that, right? Welcome, YouTube folks. Welcome, Twitch. Let me fix this run so I get this working real quick, and then I'll pull the article back up, because I do recommend folks read it. It's kind of like a nice showcase of some of what we can do with RL nowadays. I was thinking about it, and I actually think it's better than some of like the 2019 era results. Not like Dota or anything like that, but I think this is a better result than emergent tool use, for instance. Okay, so that's annoying. Just this. And we'll try to replicate it more closely if this works. So yeah, here's the article. There are very few reinforcement learning projects that have been trained on this amount of data, and all of the other ones I'm aware of are at large companies with lots of resources. Welcome, JR Sheesh. And the main result of this is essentially that we actually can scale RL, not to a huge amount of hardware necessarily, but we can scale to a massive amount of data. And we can do this in a way that you can actually replicate on like a relatively accessible hardware format. I believe that this would be based on rental prices that I saw. I believe that you could replicate this experiment for less than $100 if you were getting like good VASP pricing on a 4090 spec machine. Not bad. Dramatically more with H100s, but it's just like 3 days of training on a single one of these tiny boxes here. Okay, why are we still seg faulting? Oh, I'm not allowed to. Believe me, I should have checked that. Okay, we're just gonna make sure I didn't break the baseline. We're gonna make sure that we can actually still train this thing to like pick up the cube or whatever, and then we're gonna try to like optimize this for multi GPU because this is one of the rare cases where like the training is so obnoxiously slow and fiddly that like I can't even really do all that much on one GPU with this thing at the moment. So my goal is going to be to try to create like a multi GPU setting that's pretty much the single GPU setting, exact same training run, just faster. We can go from there. Yeah, this thing's pretty silly. 80k steps per second. Let me look into the domain randomization docs, because I think that's the next thing. Training speed scale linearly to number of GPUs. For this, it does. In terms of steps per second, it does in this. With the really, really fast environments, it's hard to keep them linear. But we are able to scale to like millions of steps per second training from stuff that's like, I think Neural MMO 3 goes from 400 something thousand to 2.2 million on 6 GPUs, which is pretty decent. We haven't super optimized it either. What needs to get done for Manyscale exactly with Puffer? We kind of just need to see if we can like make their stuff run faster in Puffer, or if we can get it to train faster, right? Like Puffer is at the moment, it's pretty highly optimized to EMs that run really fast. So the fact that these are not super fast isn't great for us because things we like to do, like running full hyperparameter sweeps and whatnot, aren't super easy to do. So it's a bunch of just like fiddling with it and seeing if we can tune knobs for Puffer that they haven't thought of before. Like you can run it out of the box, right? And like try to match settings, but the thing is we don't really want to do that because their settings are really slow. We kind of want to like see if we can get it into the Puffer regime, which is like the really high data fast sim regime, and then like get the sims to catch up with it. Okay. Yeah, so I must have broken something because we had this task succeeding before. Yeah, this task was like very clearly succeeding before. Unless it just does all of it at the end, but I don't think that's how it does. Oh, Control Freak is way too high. Hang on. Okay, so this is the original training setting. It's gonna be slower. We kind of just would like need somebody who's done a little bit of robotics and doesn't mind doing absolutely horrible things to the sim in order to make it run faster. Like from my perspective, we kind of don't care if the sim is super accurate. We really just want it to be like we want it to be very fast and like usable, and then we want to randomize the heck out of it. Funny as hell. A 46k SPS. Why Markovian property is not relevant? I think it helps when formulating a state for a new Enver problem. How does it help you do that? I mean, basically all you're saying is like, there's some function that maps state to next state. And then you're hoping it's not dependent on time. Like, that's all you're saying. How does that help you? Like, a lot of the environments we train on don't respect that property. It goes out of the window immediately with multi-agent, for instance. It goes out of the window when you have, like, observations, for instance, don't track things that depend on time, even if the state does. Like, the theoretical guarantees in RL are basically worthless. It's way more easy to think of the agents as learning a mapping, which can depend on time, of observations to actions, and that's about it. Solves pufferl eval issue. Why don't you use any IDE? Why would I? I have used IDEs before, they just kind of suck. Kind of like just editing stuff in NeoVim way more. Okay, so this works again. The baseline that we were trying to reproduce. And now we'll see, provided that this actually trains, we will see whether we can make this learn 6x faster. I think we should be able to get it to train like 3x faster at least, not 6x, but we'll see. And the reason for this is because robotic sims really, really like it when you simulate more steps on one GPU in a big batch. They like to do that, so you can't really just like split it up into 6 shards and have it be 6x faster. It doesn't work that way. You can actually make it 6 times faster by multiplying the batch size by 6. But the thing is, then the problem actually has to be pretty hard for that to be worth anything, which is what we'll get to once we start domain randomizing. Speaking of which, they have a domain randomization thing on here, don't they? Yeah, domain randomization. So camera randomization is not relevant yet. Right now, they're just randomizing the position of the cube. Pose? I don't actually know if pose is randomized. So this is going to be our next step, I think. Once we have it training faster, will be to do something like this. Okay, so this works perfectly, we see. Test once, 12.8 million, 997. We wait for this. Do I want to go over or under? I think I want to go over. We'll do 1024. And then what we'll do is we'll assume that I get 5 mil. Do like 4 mil. Let's see if this does anything. Domain randomization refers to physics param randomization, contact param density. That's another part of it, and we will do that as well. I kind of want to, like, my vision for this, right, is we make the problem, like, really fuzzy by randomizing literally everything, okay? And then we scale this thing to, like, 20,000 robots or whatever. And I forgot to edit the comment, but luckily I won't have to do this again. I have to do like this. So we're going to scale this thing to, I mean, neural MMO, it goes up to like 50K. So we could theoretically even go to that, and that would be faster. It's just like we can't start there because you don't actually benefit from having more parallel agents until the problem gets harder. And I actually don't even know if domain randomization is going to make training harder or easier. It actually can go both ways. I had control problems with not enough to observe variables and had to think about what to include. Yeah, so you don't need to think about MDP for that, though. You don't need any of the mathematical formalism. That's literally just, from the perspective of the agent, what information do you need to solve the problem? That's it. There's no mathematical formalism involved with that. Like, there's not even any RL involved with that. It's literally just what information do you need to solve the problem. We use LSTM as a default choice. It's not to mitigate the non-Markovian property. Like, the way we think about this, right? We use LSTMs by default so that the agents have memory. That's it. You can attempt to interpret that through the thing that you said, but it's going to be dramatically easier, and it's going to give you the exact same result if you just say that we add LSTM so that the agents can have memory. That's it. And then there are some problems that you don't need memory for, and there's some problems that you do need memory for. And it's pretty immediately obvious for most of them by looking at them which is which. You see what I mean? We go to the mathematical formalism in reinforcement learning when it's actually the best way to describe what's happening. But that is not all the time. Okay, so something is very weird. Something very weird looks like it's going on here. Because we're not solving the task. Fly, man. Doing things. I have to reduce mini batch as well. Oh, I probably messed that up, right? Let's do 8192. I guess this is not really a 1-to-1, so we'll see whether this does the same thing or not. It should be pretty close, though. I'll be surprised if this doesn't at least give us something, you know? Like, maybe it takes a little longer to train, but it should, in steps, but it should actually give us something that's at least faster in wall clock. Would hope. Don't need to fund math for most practical problems. It's like, it's not that I hate math, right? It's that I hate when we use math to, like, when we use very heavy math to describe very simple things, where the math adds exactly 0 additional precision and clarity. And I see it all the time in RL. No? Okay, I mean, this is, like, slightly better of a result. This should maybe learn something, we'll see. Problem is linear and interpretable. Yeah, but the thing is, if the problem is linear and interpretable, like, all this stuff is useless. Like, why are you wasting your time studying linear problems? So this is, like, one of my pet peeves, right, with how a lot of these things are taught. They'll, like, spend time making you do, like, proofs or making you, like, solve equations on, like, problems that just don't matter. Like, nobody is working on how do we design better RL for linear problems. Okay, so this takes a bit longer, but yeah, we are solving. Cool. So, and it is a little faster in wall clock, even though we have not retuned parameters or anything. Okay, so this is, like, acceptable. Sub 3 minutes per experiment. We can at least, like, make progress with things at this rate. When things get to, like, 5+ minute experiments, I get annoyed because it's like, what am I gonna do? I just guess I hang out and I yap for 5 minutes between runs. Okay, so this works. And I think I ran at 30 mil. Current reward function justified in Manny skill. Their rewards were not. I changed them and now they are. Sometimes it takes 15 minutes. You need to get real hardware, my friend. The CPUs are not real hardware for RL. And this robotic stuff is super slow. So, like, I have a server for it. But, like, all the other stuff in Puffer, you can just run it on a desktop. We have people running with, like, basically whatever GPU. You can't be doing stuff on CPU. It'll be, like, 20 times faster than if you do it on CPU in another RL library. But we can only work so much magic. Only do so much. Okay, so this looks fine, right? Here's our multi-GPU baseline. I do rel time. If I do relative time, you can see it is better in relative time than our previous experiment. So this is good. A-okay. Next, we do domain randomization. Okay, so we'll have to figure out how we do this. I think we can do RL on CyberSec. I've talked to a few people about that, probably. You can always toggle with how position rewards location combined. There was a much more fundamental problem, Sean, that I had to fix. They were doing rewards in a way that just do not make sense for standard RL outside of robotics. And like basically they had two errors that canceled each other out. And like all of robotics people do this apparently, but I did it the same way where you don't need to go make two errors to cancel each other out and it's just correct. Sometimes they provide intuition to a bigger empirical problem, as far as I can see. I hear what you're saying, Kovacs, but I've seen the way that RL is taught and it's a mess. Like if you just look at like our quick start guide and like the resources I link in the quick start guide and how much faster you will actually be able to solve stuff and understand things that matter, it's a world of difference. So basically, and this is no shame to the ManiSkill guys, okay? Because everybody in robotics does this stuff and they all do it wrong. What they do is they do these state-based rewards where they say like, okay, your reward goes up as you get closer to the target. All right? And the reason that this is wrong is because when you're right next to the target, you have maximal reward. So you're incentivized to just sit there forever and do nothing because you farm more reward. That is what is wrong with the way that roboticists specify their rewards. To get around this, they do this infinite horizon bootstrap thing, which basically says that you pretend that you're going to keep going forever, and that's the reward that you'll actually get. And they change the way advantage estimation works in order to do that. But that's going to break learning for a ton of other environments, because it basically says you get reward beyond the current episode. You don't get like a penalty for terminating. So it's a much more specialized implementation, and the thing is you don't need to do any of this. Literally all they had to do is just take their current reward, right, and take the delta from the current reward to the reward at the previous time step. That's your new reward function. And now all those problems go away. It was like 3 lines of code. Why is command line interface slow compared to importable? What do you mean, why is it slow? Do you get faster training speed? Or is it just that it takes a second to show up? Because if it's that it takes a second to show up, that's because Torch. Like PyTorch takes like a second to import. It's very silly that we have packages in Python that take like a second or two to import, but that is the state of software. Okay, how do I do this? Let me get rid of that bot. If I import, it's closer to 600K. Then something's got to be different, right? Like settings or something got to be different. The command line is literally just a wrapper around that. Could be default args, I don't know. It depends how you're loading configs. Phase RL star is fair, yeah. I mean, you see the way that we build stuff around here. It's like a lot of stuff in RL is just, it's mind-boggling how badly done a lot of the things are, right? Like, look, I shouldn't be able to make RL 1,000 times faster, okay? When a field is done competently, it's like a big deal if you make something 2 times faster or 2 times better, right? That's like a huge deal. All right, when stuff is like, I make it 1,000 times faster, that just means the original was just a total mess, right? Let's see if we can figure out this pose logic stuff. And since we do have a fair few folks on YouTube, a few quick things. One is there's a new article today. It's on X. You can get it right here, JSuarez53.1. I post all the stuff here. So if you want to see how you can do reinforcement learning on a petabyte of data with a relatively mediocre hardware setup, not a $300,000 server, right here. And then generally, I stream all this stuff live. It's all open source at puffer.ai. Or the GitHub to help us out. And you can get involved with the development on the Discord right here. Cool. Back to dev. This is slightly irritating. There's not really a way around this, but they kind of want you to subclass their stuff. Okay, fine, we'll do that. We'll make like a puffer task or whatever. How do we do this for the panda robot? Agent, robot, and controller randomization. Little tricky to figure out how we're supposed to do this. Let me just message Stone to see if he's on. Maybe he can help us get us started on this quicker. If not, I'll just figure it out. Load agent, load scene. A custom environment when you load the scene. We definitely need to just get a base scene loaded. Let's do that first. What is epoch? Epoch is the number of training steps that have run. Like, collect a bunch of data, you train on the data, that's one epoch. Cube.py. At register env pick cube. Any skill ends tasks tabletop. Pick cube. Pick env. Okay, so now we're going to just temporarily force this to be tougher pick cube. And I guess we can pass all this stuff directly, maybe? Not. Hopefully we can get a good domain randomized config quite quickly here. We'll see. I think I know how we should go about it. If we just open up the source. I believe they randomized the goal position. Oh, maybe they don't randomize the goal position at all. Actors.buildSphere. Pose. This is 0, 0. Kind of confusing, honestly. I don't know where they're setting positions and things in here. Okay, so this works apparently, but I'm not seeing any logs, so something is screwy. Maybe we should just do like this, yeah? Go through the register. Episode and epochs are the same. No. So an episode, well, where do you see episodes? I don't think we record that as a stat. You see episode return and episode length? That is for like one agent's interactions with one environment. How long is that? So how many steps? And then what is the summed reward? The epochs is like a bunch of episodes. A whole bunch of episodes are in each epoch. Does anybody understand how they have this set up? Cube spawn center. Register env is not defined. Okay. Goal XYZ. Okay. Pose.create from PQ. Position quaternion, okay. So this is randomizing, I believe, just the initial cube site. And not the... Is it the goal? Oh, no, it is randomizing the... some aspect of it. Okay, so this runs now. We'll make sure that this trains. We actually do have our ability, though, to mess with it now. Oh, I understand. So this is just loading all this stuff, and then on initialize episode, they move the thing. So really all we need to do, change the initialize episode potentially. At least for now. And we should also probably get this on our local. So that we can render stuff. Okay, so this is the default setup. It does randomize the cube's position and the goal. So it does drop it occasionally as well, which is interesting. Okay, so this works. We didn't break the environment. Now we can attempt to break the environment. This. You need this. Start with. Do we... Let me see. Does this always start the robot at the same spot? Looks like the robot's pretty much always in the same spot, right? Table scene. Robot. Tell you how to move the robot, agent, robot, and controller randomizations. Jen? Ripper frictions, render materials. Yeah, this can be done during initialized episodes. Environment episode return is the param that tells us the agent is learned. It depends on the environment, but yes. Some environments have a score. Most of them should have a score in Pufferlib. That's the actual like metric you care about. Episode return is the summed reward. The metric the agent sees that it's optimizing. Slightly different, but they'll both tell you things. When it's flat, it means the agent's not learning anything. If the score is flat as well, then yes. Join. How do I make the robot start at a different spot? Like, what is pros and cons of num-ems? It depends which num-ems param you mean. If you set like a lot of the envs, like vec num-ems param to 0, like to 1, it's not gonna learn. If you set env num-ems to 1, it's not gonna learn anything. If you set those to 20, then you're going to have a ludicrous number of agents. Like if you change the default to 20, you're gonna have like 20,000 agents in parallel. You don't have hardware for that, and then only some of the environments will benefit from that. What the heck? Helicopter just went over, flying super low. What's the ideal for CPU? The settings that I have as defaults are probably going to still be roughly ideal because, like, you'd have to rerun a whole sweep just for CPU if you want to see what the fastest solve time is. At least the settings that I provided I know work, right? Robot init Q pause noise. The robot init Q pause noise. Can I crank this up? Can I just like crank this way up? What happens if I do this? Then the next thing, whoops. The heck, pose is not defined. Oh. This is everything in here? So this should make the robot start at all sorts of different spots. Yeah, that works. We can change the robot like joint stuff. That's probably important. I wanted to change like size of cube and stuff. Cool, Stone's replying. Starting to learn. Ah. But here has failed, it seems. Starting to learn. See if we just can run it for longer. A lot of things you can change in theory. Soon. Gym for everything must be rough? No. Why would I do it this way if it were difficult? I do it this way because it's easy. The one annoying thing is I don't have my Neovim on the tiny box, so like my autocomplete and stuff isn't working nicely. I have it a little bit nicer locally. I've used IDEs before. They're just slow and shitty. This is what it looks like. Better. Okay. This is doing something now. Cool. See if it's stable. So let's see, there's collision meshes, visual meshes, point PD, mass inertia, initial mean joint position, controller choice. Most of these are not exposed directly. We have to be a little careful not to do stuff that just makes the task impossible. I don't think that's what's happening here, though. It seems like unstable learning or something. Set it to 0.1 for now and see what happens. 'Cause I don't want it to like spawn through the table or something, right? Mass inertia, point PD. pose equals random quaternions How do you fund this project? Do you work somewhere else? Puffer is a company. So we have a couple companies that we work with. Generally, you can hire Puffer to help with your reinforcement learning efforts. You have all sorts of tools. Reinforcement learning is hard. We make it easier. Generally, a lot of our stuff just solves a lot of problems out of the box. The ones that it doesn't, we help with. Okay, so this initial pose at least gives us some reasonable success rate here. I don't know if this is going to be stable. Yeah, this seems like it's unstable a little bit. At. Still don't even know what the observations are, right? What are the observations? Okay, so they have added the object. Grasped, pose, full pause. Modify the task. Okay, yeah, this is stable. Cool. Pose.raw pose. I need to understand what this data is next. Pose fully. Cue pause noise. Okay, cool. Not super stable. TCP pose. Need to understand whether this is reasonable next. Just stick some breakpoints in here and start looking at data. Raw pose. Okay, so this is the pose. To obj pose. Okay, this is interesting. The cube also has a 7D pose. Position and orientation of the robot. What is environment? This is Manny skill. This is a robot picking up a cube and moving it to a goal. So is this position X, Y, Z, and then like a quaternion? Is this what it is? Pose.p. .p. Then .q. Yeah. Environment / n on your ocean n. Oh, n is the number of data points that were collected in displaying that summary. Last four straight up like quaternions, yeah. So that's weird though. It should have more than this, right? A robot is described by a root pose and joint angles. Hit cube only. It doesn't have anything to do with the cube though. It has to do with the robot, right? The robot is like 6 degree of freedom or whatever arm. Always given to the You always provide Q pause and Q velocity. Extra obs past specific data. Okay, I see. Yeah, so apparently there's a base observation for all the robots. M sapien N. Get obs state picked. Get obs agent, get obs extra. Get proprioception. Grasping, aesthetic. Get get looks like a pain. Yeah, it is a pain in the ass. But it's dramatically less of a pain in the ass than the other robotics libraries. This is like less, believe it or not, this is like less overly abstracted and ridiculous by a mile compared to like Isaac. In base agent. Oh, agent, there's a base agent. And then this calls get state. And get Q pause, get Q velocity. State. Do we have a get? Okay, so they actually are including then the information that seems mostly reasonable. I think that this is mostly done correctly. I guess it's difficult to know because of the coordinate schemes, right? Okay, so this is one that actually has like a pretty simple reward that's probably correct. Then what makes this like remotely difficult or interesting, I guess is my question. Right? What makes this remotely difficult? Probably just comes down to randomization, no? I do it here. Builds all objects in all parallel m's and share same physical properties. Boards are dense, so it has to work unless there's a problem. So it works, but I'm trying to figure out what makes the problem like remotely difficult to learn. I mean, to be fair, it does learn in like a ridiculously short number of time steps by like our standards of our other environments. It's just that the env is so unbelievably slow. That's the main limitation more than anything, is just it's an order of magnitude minimum too slow. like minimum. Full center point. Okay, so this is competently done. I think what else I can mess with? Okay. On. Here's a thing I can try. Can I do 4096? Can I do this? This is 280K. We should track this. Go explore style thing. I think I see now with like robotics how you could do this from just a couple demos. I don't think what we have to do with that. Just loading some states. being the issue, right? Is that it doesn't learn anywhere near as well. Getting started with RL, welcome. This is the place for it. I think we're just gonna have to run a bunch of random experiments with how slow this thing is and hope we find something to start with. Like, it's not like it doesn't work, it's just not optimal. Yes. First thing to try that's kind of obvious. It's already a massive learning rate, but you know, screw it, why not? It's just like it's annoying that this is basically they've kind of like managed to bring RL back to the dark ages with the slow sims here. Realistically, I'd have to add multi GPU sweeps, I think. Try to increase action limits. ARM PD cause delta. Why is it not learning with you're using 32,000 environments, that's why. You have a huge number of environments for a relatively simple problem. It's not going to benefit from that amount of parallelism. Because the config for that env probably doesn't have env_num_m set to 8. Got this from your example? Which example has that? Portable? Oh. Yeah, that's just showing you like a random that's not like meant to be a good config for whatever NVID is, right? Just showing you the API. Visual will be barely parallelized to 1024 ms per GPU. Trying this. Okay, this does something, but I don't think it learns like fast, right? Yeah, so this it learns, but it takes forever here. That doesn't do it. Go mess with the Panda controller. Okay, so that's make the robot faster. Okay, this looks better, right? Are you running multi-env? You're running multi-env 4096. How come it's slow? This thing here? This is slow because this is a robotic sim, which is just slow. It's not a puffer env. Our puffer envs are fast. Okay, so this learns like maybe a little bit faster. Okay, so increasing the actions kind of did something. I'm gonna go like just 5x the force limits and stuff as well. You say it's slow as comparing apples and bananas. Whole engine's doing tons of calculations. Honestly, it's like 6 degrees of freedom in 1 cube. I think it's kind of just slow. Like, particularly when I look at the code and how the code is written, it's like, I bet it's just slow. If I want to write an NVC, what do I have to do? We have a tutorial for that on the docs page. I'm thinking about it, and it's like, there's no way you wouldn't be able to run a 6 degree of freedom arm at like millions. Totally should be able to. Really not doing anything that crazy. Ah, lovely. So it crashes. Okay. You find sweet spot for training config? Not the way I'm doing it here. For automated automatic sweeps. Don't do what I'm doing here. Crazy contact sim? With what? There's nothing for it to contact. Puffer sweep. It should also be in the docs. We have a sweep. We have like a really nice hyperparam sweep algo built in. 5. See if this does anything. I'm just kind of YOLOing a few things here. Because, like, the way that it's set up just can't be. It, like, just can't be the best way of doing it. There's just no way you need to have it be so high fidelity that it's low. Help me find the best config? Yes. Alright, we'll see if this does anything. This should allow it to just, like, flail about very, very quickly if it wants to. Not also getting limited by max force. Ignore it, okay? See if this learns anything. Realistic collision checks for complex meshes, even though they are rectangular. Realistically, considering a lot of realism. Well, then they shouldn't be doing that, right? The idea of, like, I want to train a good robot, therefore I will simulate this thing as realistically as I possibly can, train it on that, and then deploy it. That's just wrong. That's not how it works. Because if you just have no data, right? If you have basically no data and it's very high fidelity, it doesn't matter. I'd rather be able to train something at relatively lower fidelity with a ton of randomization such that I get a really, really robust policy out of it. It doesn't matter if I can simulate physics if I have something that can, like, work correctly on basically any sort of janky physics setup that you give it, right? That's the idea. How will you deploy it? Because if it works on any randomized set of physics, collisions, etc., if it works on like all randomized versions, then the real version is in there somewhere, right? So think about it, right? Option one, you make it as realistic as possible, okay? And then you train it on that. It's really, really slow. And you deploy it, and then your sim is not exactly like the real world, so there's still a big annoying gap. Right? Option two is that you randomize the heck out of everything such that you're not remotely training on something that looks like the real world, but the real world is in there somewhere in all the configs that you have. Elizabeth is determined by the sim to real gap too. Kind of, but it's easier because like domain randomization gives you a big wide distribution over the real, like over. Well, it gives you a big wide distribution that hopefully the real one's in there somewhere. Okay, yeah, so this is taking longer to learn with random action. So my guess is that it's just like something very janky going on here. Roll, I don't agree with you. I mean, something's got to give because the Sims are just abysmally, horribly slow. Like, you're literally in the dark ages where, like, nothing works because you have no data. This right here is running at less than 5% of the speed of, my more complex ENV training runs. And like 100th of the speed of the faster ones. For like a really easy task. Like a task that when you look at the task and you assess the difficulty of the task, like it's trivial. You have this being this slow for a problem that is trivial. And this is the thing that we found with reinforcement learning as well. Stuff feels really difficult because it's slow. That's it. It's like, this is why you had like generations of RL students like working on Pong and stuff, right? Like, well, was Pong hard? No, it was just slow. You can't optimize like all the experiment settings, all the hyperparameters suck. Okay, all the environment settings suck. Okay, like literally nothing is optimized correctly at all because you can't run enough experiments because it's slow. Exact same thing happened in the rest of RL. Like a 1-to-1, same playbook. How to best understand config from sweep command. Yeah, so Neptune will give you logs, and you can see which experiments are the best, and then you can kind of just pick one and grab the config parameters from there. I mean, super annoying, man. It's like I can't even really like the thing is I can't even really get into this type of stuff I'd want to do with the way this is set up. It's like not intended for the type of stuff I want to do. Do you have any war sims? Yeah, the one I was working on the other day. At least do this. Wouldn't sacrifice the realism. Let me see how I can convince you of this. Becomes quite like literally this is all I'm asking for, okay? Take literally every single physics parameter in here, right? Like every single like, you know, force parameter, gravity, inertia, like just take all the parameters, okay? And then define some like percentage based interval over them. We should be able to tune the magnitude of that interval. And then all the other parameters, that's like solver, fidelity, and updates and all that stuff, should also go into the tuner. And then we should figure it out automatically and algorithmically. Roboticists are not doing that at the moment. They're kind of just assuming that they just make the thing as slow as human, like as slow as they can possibly bear. And then they just run their really slow experiments and hope it works. Horrible contact simulation. Possibly. Is that a hardware thing though? Like, can't you get around that with other types of grippers? Can't parameterize. The dynamics are cost rate. I don't see any fluid dynamics or cloth draping, though, is the thing. Like, look. I don't see fluid dynamics. I don't see cloth. I see ultra basic rigid body physics, right? With like a literally trivial task. Hang on, wait, let me show you the one that I'm looking at. It's like pick cube. Okay. If you want to think about, like, in terms of how complex is it, like, to learn this behavior from first principles. In my head, this is like Pong. This is like nothing. We kind of just get sensor data. Okay, easier than Pong. I mean, like, seriously, isn't it? You're picking up a thing. What is the decision making involved with picking up a thing? It's like a few joint angles. Can't you spawn more than 4K? Yes, you can, but here's the problem. The thing is, really simple problems don't lend themselves to actually learning faster with more environments. Serial. As the environment gets harder, you can benefit from more parallel M's. The thing is, this is just a very bad combination. It's a simple problem that's really slow. Simple and very slow. Do you know how long it takes us to learn Pong in Pufferlib? 3 seconds. It takes us 3 seconds to learn a 20 score Pong policy. It has to learn pretty fast. Yeah, the thing is, it just doesn't learn fast because this number is 20 times too slow. Actually, more than 20 times too slow. Pong trains 20 times faster than this on a sixth of the hardware. So it's over 100x too slow. Can I see the rewards again? The rewards are very sanely defined. I will show you. So this is how they compute a dense reward. Okay? They have a reward for reaching the goal. And then they have a is grasping term. You only get a reward for placing the object if you're actually grasping it. And then I have the static reward. These are state-based rewards, so completely wrong. But what we do is we take the delta between this at this step and at the previous step. So delta of reward at this step to previous step tells you progress towards goal, and that's what we use as reward. I don't know if we're getting hit by a hurricane or what, but everything is rattling and shaking. Huh. Those are some pretty high-speed winds. Hopefully this doesn't take out the stream. We'll see. Takes a lot longer to solve here. Why do you do that, and what's wrong with this reward? The state-based rewards, when you get close to the goal, you'll just hover around it forever, and you'll not actually solve the task. This is a wrong way to define rewards, and then what the roboticists do is they modify generalized advantage estimation to bootstrap on terminals. What we do instead is we just don't do that and we use delta rewards, and it's the same thing. Actually better, because you actually get more fidelity out of your reward signal. It seems pretty easy. Well, we do solve it. It's just like, it's proven annoying to get it to solve faster. Right? I can kind of try to just guess a couple things. What if I just guess? Yeah. That's basically the problem. The thing is, it's not that my it's not that my advantage estimate is wrong. Right? My advantage estimate is right. In general, the robotics version of it is wrong. At the very least, they have a specialized JE that doesn't work with other types of tasks. Mine will work with both, provided you don't define the rewards insanely like this. Very weird to me how volatile the rewards are, you know? I do wonder if this is a scaling issue. This is way worse. Makes sense. I see. Lower learning rate. What if you continuously increase the reward? So because you clip it off at the last state, it would rather stay right next to the goal, right, than get reset to the start where it's gonna get very low goal, like a very low reward. Yeah, so what it's gonna do is it's gonna like go right next to the goal and then just sit there, and then if it's a smart, eventually it'll figure out to touch the goal at the very end, but probably not. Add an action to predict the termination. The way easier solution, right, is to just not define your rewards like this. This is not a good way to define rewards at all anyways, because like you compress the entire signal as well. The delta between one state and another state might be very small in terms of difference in reward. Interestingly, doing very badly. Comment gamma. A ridiculous gamma though. I guess it's because it's a dense reward. Never trust no RL algorithm to work on a new env ever. The thing is, ours actually does. Like, we got it working on this pretty quickly. As soon as we fix the rewards, we have it working on this new env in a new domain that we don't do, like out of the box. It's just that here the env is very slow, and we would like it to be faster. So I'm looking for settings where it's faster and we can still learn. But yeah, actually try the Puffer 3.0 trainer. It actually works out of the box on most stuff. It's kind of crazy. I wonder if I ought to just, like, sync this up to the environment resets, you know? I think you can. Okay, so it suddenly is at least, like, somewhat better. Yeah, but it looks like the hyperparams we swept from before are, like, overall reasonable. Not terminating the end in case of this at all. Then you'll stop learning because all the agents will get to the goal position and you just don't reset. You're getting worthless data. Okay, let's hope my roof is really good. Because, this is a gale outside, my gosh. Holy. My microphone should mostly be filtering it, but it's, rain on a metal roof. So. Very loud. Ah, look at this. Okay. So this is at least relatively cleaner. And nice and stable. Now, my question is, with these more general hyperparams, where we haven't, like, maxed the learning rate, can we go up to 4096 ends and 384? $32.76. This work now all of a sudden. And to be safe, I'm getting a very high quality conversation on RL, which I can't get it all in the day. Yeah, I mean, this is the place. Look, I don't even really do robotics. We're kind of just doing this as like, yeah, robotics is another RL env. And it's not like we're failing, right? Like, the stuff works. It's just that I'd like to find some settings to massively improve the speed here. But the thing is, like, my intuition here is just that, like, this thing has been, I've seen this all the time in the rest of RL, right? You have like an environment that's been very heavily tuned to work in like the defaults. It doesn't mean that there aren't other ways to set it up. It's just very annoying and like a lot of work. My guess is that like if you actually have a very heavily randomized setting with way lower fidelity solver params, my estimate here is that it actually will do just as well, if not better. So that's what I'd like to do, but it's kind of becoming clear that it's pretty tough to set that type of stuff up. I at least want to see if we can like get something that's meaningful though. Like some sort of meaningful improvement to this thing. So we will see. This is like the reward is just not quite doing it for us. Okay, let me think about this. I could keep the mini batch small, right? How would you define the reward for this problem? Can you elaborate on this? Because I'm bumping this into a spot. Well, I actually have it. So the reward I showed you is not what I'm training on. That's their original. Okay, the reward that I have is literally just that reward that I showed you computed at the current time step minus that reward at the previous time step. So that tells you progress towards goal. It's unfarmable because if you stay at a point, you get 0. You can't go back and forth because that just averages out to be 0. And you get a positive when you go towards the goal. This will work for like any of the dense reward signals that the roboticists have set up. So like literally they were a 3-line change away from having it here. Little bit off. No? This doesn't work. Let's hypothesize. Hypothesize a little bit here. Start with 96. Is the original reward good at all? Uh, it contains good information, but it's not presented correctly. Let's put it that way. So literally, if you just take their reward signal and make it delta instead of absolute, it works. You don't need to do IRL, like inverse RL. The thing I've given works, right? This does work. We take some more steps than they do to solve it, but like we're literally training one update epoch as well. I haven't messed with that a whole bunch yet. So you have a totally new env. How would you design one? I can't really comment on robotics because I don't do like a ton of robotics. Their rewards are like They're very manual and kind of a pain, but like I see why they do these things. They're just posed wrong. So when I design new environments and I have rewards, I usually do the simplest thing possible, right? Like I start with just success, and then if it's like obvious that that's way, way, way too hard to run into, which is like basically if you take random actions and you're never gonna get the success condition, you can't just train on that. So then I try to do like the most light-handed intermediate reward I possibly can, usually some sparse thing, right? And then if I end up with more complex M's that have like 3 or 4 different reward coefficients, then I just like I think, okay, here are 3 or 4 important things in the environment. I don't know what their relative weighting is, and I put them into a hyperparameter sweep. Welcome, Savelli. Thank you. Yeah, I actually was just going through all the YouTube comments this morning. I was like, hey, actually, surprisingly, YouTube is way, way, way happier about all this stuff than X is. X, they're always mad about everything. People here are pretty chill. Okay, yay, this actually kind of works. Is it better? It's like kind of good. This is like kind of good. Okay. Oh, actually, this is quite good, isn't it? Because if I do this, look at that. Yeah, that's our fastest solve yet. 2 minutes. Let me think if I can make sense of what I even just did. I kind of just guessed. So I reduced the total batch size by a factor of 4. I can try 8. This is where things start to get sketchy. I can try 8. If this works better, it just means the problem's trivial, by the way. Which is kind of expected. Like, they use 4 in the original. Like, this parameter, they use, like, 4 steps. Which is crazy. Like, absolutely crazy. Why don't you use different algorithm? What do you mean? We have, at least as far as our online learning goes, like, we kind of have the best thing already in Puffer. We don't, like, hop between a bunch of different algorithms. We just have the best algorithm. This, hey, Reg, this is also not exactly PPO. Like, the changes that we have in our implementation are substantial enough to consider it a new algorithm. And, like, in performance, it's a generational advancement over PPO. And I mean that for real this time. Not like all the papers that claim to be better and, like, actually aren't. This one's, like, for real better. Sounds like a paper material. I'm so sick of papers. We have some blogs on it on X. If you want all the details, it's all open source. The idea that every time you come up with something useful, it has to be exactly 8 dense pages of really boring content is like that takes a year to review is like kind of ludicrous. Get to a place to make a pitch. Yeah, I do that. I mean, like with the I have like a good chunk of the RL audience on X as like already. If you look at like the biggest pure RL accounts, and then you look at the size of mine, they're pretty close to comparable. Particularly because I really don't have followers from like other stuff, right? They're like professors and things that have like they post politics and other stuff, and they have larger accounts. But like as for people that are just there because they post pure RL, it's pretty good. You think that those people on X are real? I mean, yeah, I get messages from researchers all the time. Okay, so I was kind of expecting this to work. The fact that it doesn't is actually kind of a good thing. What license does Puffer use? MIT. It's all free. The only thing that we sell is we sell our services, right? You can use all our stuff for free, but if you have an RL problem and you're having a hard time with it in industry, you can hire us to help. That includes like support and features around Pufferlib. That includes direct work on your problem, custom simulation work, all that type of stuff. Segment filtering, topic stuff. Okay, so we're at 16 Horizon was the good one. I guess we just see if we can mess with fidelity now, right? Does this still learn? We should, in theory, be a little bit more robust to fidelity now, because we have massive batches. Hellstone. We have a good number of folks on YouTube today. Hello, welcome. And if you're new around here, this is just all sorts of reinforcement learning research done live. It's all open source. If you want to see a bunch of demos that are not me just staring at training graphs, because we're doing fiddly robotics today, we have all sorts of stuff at puffer.ai. Click Ocean, you can see all these different demo M's. We have everything from like drone flying demo to games, like this type of a thing. And the agents all run in your browser, and many of these were contributed by brand new people with like zero RL experience coming in. So if you're interested in getting involved in building crazy stuff, oh yeah, I like this one. I built this one. Each puffer is a different agent. If you want to get involved with this, you can join the Discord, which is just discord.gg/puffer. You can also help us out for free by starring the GitHub. You can also follow me on X for more. If I have stalled long enough, maybe the policy will have trained. Kind of. Is this stable is my question. If that's a stable 400k, does take longer steps. Where's RL used in industry side aside from releasing things R1? Or is it just catching on? It's a lot of random problems. Like RL is basically anytime you have a sim and like a fiddly unintuitive optimization problem. We've done all sorts of like weird random things. The thing is, like, RL has just kind of been cast to the wayside because nobody could get it to work. But like nobody could get it to work because everybody did all the engineering wrong. So just in the last year, we've made so many things 1,000 times faster. We've been able to like make some fundamental algorithm breakthroughs. We've been able to like really, really hone in and optimize a bunch of things. And now it feels like a different field at the very least. If nothing else, it feels like a totally different field from before. Okay, this is actually pretty solid. We're at like 2-minute solve. Super low fidelity. Can we crank up control? Demos on the website are fun to play with. Thank you. We had to do quite a bit of stuff to get those to work. So all of those agents, those are running like pure C versions of the neural nets that we trained in PyTorch. So we take the PyTorch weights, we load them into like this single file C library that we made, and then compile all that to WebAssembly, including the environments. What do you think about VLAs? LA. VLMs or VLAs? What's a VLA? Very large action models? I don't know. Action models? Eh. If you get enough data for a specific enough problem, sure. I kind of really don't care what's happening in the world of like, let's train massive, like ridiculously sized models that are super slow. Because like, it's kind of funny that we're able to like solve like individual problems in seconds with these like absolutely tiny models that you can just deploy anywhere. And like obviously this is a lot newer in the sense that it hasn't had billions of dollars of investment poured into it. But like you can kind of see just from the progress we've made in the last year where some of this is going. Okay, I mean, so this now works. So this isn't a thing that they thought I would be able to get to work already. That's exciting. Can I do... Let me think about this a little bit carefully. VLM with imitation. Any wisdom on meta-learning hyperparameters? I've been going off the heuristic that if Puffer doesn't do it, then it can't be great. Yes, except there's one small caveat, Finn. There was one quirk with our hyperparam sweep algorithm that I could not fix in time for release. If you see that your problem is forcing all the runs to be the minimum number of time steps that you specify in the sweep, you might want to try with one of like the downsample equals 0 configs. And what that does is that basically it tells the hyperparam sweep algorithm to not try to learn using the entire training curve, to just use the endpoint. And that's kind of needed for some of the environments. That's the only stumbling block. Let me think about this a little bit more principled if I can. If I just hit 40 here, does this do anything? Let's actually see what this does. I'm curious. I think this just gives you like additional fake frames. Gives you a lot of fake frames, though. Like approaching a respectable training speed. Hyperpram free RL ever be possible? I will say this. The defaults that we have in Pufferlib work on like almost all the environments. Like they work out of the box on a huge number of problems. So we're getting closer to that. I think we could get to a point where like we have defaults that work pretty darn well out of the box on almost everything. The main thing that is not solved yet is gamma. So generalized advantage estimation imposes a horizon on your tasks, and it's really screwy. So we would have to like, we'd basically have to come up with a replacement for generalized advantage estimation. That was through a search? Yeah, but the thing is, we did the search once. Alright, we did the search on like breakout, and those same parameters work on like at least 6 or 8 of the environments. It just works. I think more like 12 of them, actually. Really, the only ones it doesn't work, like, the bigger models need different learning rates, and you can show that. You need to decrease the learning rate, and then there's some environments that need different gammas. Model-based, dynamics-based agent can solve the hyperpram. No, they can't. How do you figure? What part about having a model solves hyperparameter tuning? If you quote the Dreamer paper, I'm going to submit a different academic paper back at you. Fair warning. Mr. Q, I've been meaning to look at that. It's like a big paper. Been meaning to look at that. Well, there's something to model-based RL, I think, but the thing is, like, it's like the rest of RL where all the science is done absolutely horribly. So it's kind of hard to tell. So this thing just doesn't do very well. Okay, can I fix this? Let me go find the thing that he told me to adjust. ARM PD joint delta pause. ARM PD joint delta pause. Okay, so this is what he told me. This is what he told me to mess with. So let me see if this does anything. Efficient 0 v2. I actually think some of them use zero line of work makes more sense. Like, that makes more sense to me, some of it does. I think a lot of the algorithm work I want to do will look at off policy as well as model based, but like we kind of have to just throw Pufferlib on a bunch of different applications first, right? In some more industry traction. So if this doesn't work, then there's something that's not behaving as anticipated. Because technically, if we double the sims, like if we double the control frequency and we double the actions, it should work just the same. I'm gonna run this first to make sure it doesn't actually work. I mean, there is a difference. But it's not like massive. Reward really jumps all over. Yeah, so this is very similar to the previous. How can you run multiple sweeps in parallel? Like for different environments? You can just launch different processes on different GPUs. We don't have the ability to use multiple GPUs in the same sweep yet. That is something that we should add. We do have the ability to do multi-GPU training. We don't have the ability to use like multiple GPUs where each GPU contributes to the same sweep yet. That's one of the things I've been meaning to add. Different process? What do you mean? Out of here? See ya. Thank you. I do this pretty much every day. See, this is obnoxious because if we could get this to work, like this is the theoretical max SPS that I've obtained with this, right? Like pretty decent. YouTube comments pretty slow. Yeah, the latency is a little better on Twitch. Not much I can really do about YouTube being YouTube. Let me just try one weird thing. Just in case. Like, just in case. Which is that technically you have to increase gamma with the way it's defined here. Because you create a longer horizon problem. Turn kind of just gets stuck. Irritating. Yeah, dang. Okay. Go back to the original 20. Can I do like this? Let me see if this is still stable. See if we can send Stone a cool policy. Okay. You managed to train 2048 and put it on the website. I have not done that yet, Yannick. I need to do that, though, because that is a cool environment. I've been sidetracked by robotics and other things. You have a cool new article up, though. You want to figure out, if you want to hear how we did RL on a petabyte of data, one server, there's a nice write-up here on X. Wrote that this morning. That's up here. I did. If this is stable. You have fully integrated multi-GPU. Yes, we do. You're looking at it here. You vec the env. No, that's not how you do it, and that's not how you'd want to do it. If you did it that way, then you would you'd multiply the overhead of any CPU operation by the number of GPUs. So we use Torch Run, which launches independent processes per trainer, and then DDP just averages the gradients. Imagine this should solve, right? Not bad. Does it scale? 2 GPUs double as fast? Depends on your environment speed. If you from the article, right? 2.2 million training steps per second for Neural MMO3, compared to like 400, between 400 and 500K on 1 GPU. Pretty good scaling. To be fair, that's not even completely fair because there's like some CPU conflicts as well, doing Neural MMO like that. Overhead there as well. Depends on your environment, can be linear. Okay, so 2 minutes, 30 seconds. Amusingly, we've managed to take more steps to solve in about the same amount of time. But the hope here is that this will now allow us to do better. We wanted to preserve the number of gradient updates, make learning more stable. What happens if I do like this? Let's do 16384, update epochs 2. That should be the same number of updates to the policy, but more stable. Welcome to all the stream's been doing well the last couple of days. Welcome to all the new folks here. We'll of course have to actually look at the policy. I don't want to run too many more of these because I got to run for dinner a little bit before 6. I'd like to be able to look at it. Good work, thank you. I'd like some of these articles on X to do better. I mean, they take quite a bit of time to write. Amusingly, like the literally like AI clipped shorts out of the stream have done like surprisingly well on YouTube. They get like over 1,000 views. I think one of them got like 2,000 something. The other got 1,000. They're just like literally clips from this random stuff I do. I don't know what's up with the shorts algorithm, but I don't know. If I do anything like interesting, like an explanation of something or other, I might just start adding those. Okay, so are we not stable here? We're comparing this one to this one. We have something more. We have this metric. Huh. Yeah, see, this is one of those weird things I can't even explain. This should pretty much always be strictly better. Oh no, it does track. Hang on. It's actually starting to track this. Okay, so it's pretty close to comparable, which means that we're not really benefiting from larger mini batches. Played with a couple config params, got a good run in 15 minutes training multi-GPU. Solid. Yeah, we really need to do multi-GPU sweeps, I think, Spencer. I just haven't had the chance to add it. It kind of takes a little bit of work. Do this instead. So this is doubling the number of updates. It's a very different thing. This will be the last run we'll do. After this, we'll the last new run we'll do. After this, we'll train our baseline. We'll grab the policy. We'll output some rendering, and we'll call it. Alternative title for stream will be "Watch as I horribly break all of your Sims, roboticists," in order to make them actually run quick as they should. "18 minutes. Got 6 G, not 5. Yep. What do you mean you forgot 6 G, not 5? How's that affect the time? Change the axis to rel time and you call it a day. Okay, this is getting lift. Yeah, now that we have all this stuff like total chaos, or update epochs does something. It's kind of hard to see, but this is the green curve down here. This was our baseline before. And now it looks like we're getting lift here. Hey, there we go. That. How far away if you do from doing something like OpenAI 5 if you can already train for such a long time? Two problems with OpenAI 5. One, no matter what you do, you will need 50,000 CPU cores to run Dota. All right. And two, the observation structure is really obnoxious to make fast. So I think that the result, like I wrote in the paper, I think that the neural MMO result is a better result than emergent tool. Dota is still pretty hard. Okay, this is a very good result. So we're happy with this. Can I go to 4? $99.5 to 99.6. 99.9999 required, Spencer. Make the thing be perfect. Everything. Literally need to be able to just run the policy on an actual car and have it somehow work. There's a car that's physically in the way, and there's another one behind you. There's no way to escape. Quantum tunnel through the car. Figure it out, man. The environment Spencer is working on is a collab with NYU. You can actually fiddle with pretty darn recent version of it on the website. Of all the cars, you can actually hold like space and go into first person mode. And it simulates these like short little driving scenes. We're adding much longer scenes to this as well. Yeah, it's pretty cool. New York University, yeah. There are a couple pretty cool RL labs over there. Sadly, not a ton going on at MIT at the moment, as far as I'm aware. Otherwise, we'd support them. But a little annoying. Okay. Slightly worse in terms of time than the previous one. We'll go back to 2 update epochs. Hopefully this saves a policy for us. I don't know if I'll get to actually check it before I gotta run for dinner. In case I do have to run, because I'll have to just go all of a sudden. For folks watching, Puffer.ai for all the things. Start the GitHub to help us out. It's free. Really helps us out. It's all open source. And yeah, join the Discord if you want to actually get involved with building some of this cool stuff. We've had several people come in with like either no AI background or even some with no programming background. been able to get up and running pretty quickly. Like, we try to make it pretty easy. There's also there are a whole bunch of resources on here to help you as well. The blog, we have more articles on X, lots of things. Okay. Go get Stona a couple of screenshots from this. For dropping by. It's a pretty good result here. I honestly don't even know if it needs a bigger network at all. I think that's a new peak for the stream. That's I can never tell how many on X, but that's at least 14 concurrent. So cool. Thanks for dropping in, folks. I gotta run for dinner. I will be back either after dinner or tomorrow. We'll see how I'm feeling. And I'll keep working on robotics, large-scale tactical battle end, and all that. So thank you, and have a nice evening.